Right. Well, we have sound, I hope. We have vision. And welcome to Chemistry Topic by Topic. We're going to have a look at today at states of matter. And we're going to have a look at the cooling curve of stearic acid. And then we'll see how we go for the time after that. States of matter. Well, we all know what those are. So let's jump in straight away and check we know everything about that. What we've got for states of matter are basically three of them. Zoom in a bit. We've got our solid, we've got our liquid, and we've got our gas. There are three states. And in physics, we have a look at this and we are concerned with these, and we do the same in chemistry. So I'm going to cover the same information that we do in that topic. Firstly, then, to go from a solid to a liquid, we've got to undergo some melting. And this is what I'm actually doing at the moment. Over on this side, and it's going to come online in a sec. No, it's not. Okay, I'll talk for a moment. I've got some stearic acid melting, and we're going to have a go at an experiment with that in a minute. If we take a liquid to a solid, then we've got basically freezing. And that's an experiment that I want to have a go at in a few minutes. It's ready now. We'll have a look. I've got here sitting in some hot water, some stearic acid, and at the moment it's melting. I've got the thermometer in here, and what I'm going to do in a little bit is we're going to take this out and we're going to watch this cool and see what happens. So we've got some stearic acid in hot water, and we'll have a look at that. So that's just cooking at the moment. Right, back to me, and we'll have a look at this idea here. We've got a liquid goes to a gas. Two names here, I suppose. We've got boiling. Can't spell today. We've got boiling, and we can have evaporation. Evaporation takes place at any temperature, more or less any temperature. Gas going to a liquid, condensation. Few substances go from a solid to a gas in one go. Carbon dioxide's one of them, iodine's another one, and we call this sublimation. And the final one, where gas just goes to a solid. The courses don't ask you to know this, but why not? We've learnt the other five. Deposition. So we've got these different states of matter, and we're going to have a look at these states of matter using a little model to try and show what's going on. Let's have a look and see this. Now, I've also got here another set. Can you operate the camera for a minute? And in this tube, I've got lots of little beads. Some of which have escaped already. And what I'm going to do is I'm going to actually take some of the beads out, so we've just got a few to play around with. There we have managed to scatter quite a few around the surface. Now, these little beads are going to represent some atoms or molecules, and what we're going to do is this is a loudspeaker, and it's going to vibrate. And as it vibrates, so these little beads, I'll try and put the ones in escape back in. Most of them. They're going to vibrate. I don't want all of them in there. Shows it better. I've got AC power supply, and this I'm going to put into a resistor. I'm still picking up beads here. So my circuit is going to go from 12 volt supply into the rheostat. We're going to come out of the rheostat into the speaker, and we're going to go from the speaker to there. Hopefully, I've got just a little noise going on here, and let's see if we can calm this down. So my molecules are just vibrating. We'll put a few more in. That's going to help the matter. And what I want to have is these molecules just moving, just vibrating. There we are. Now, the molecules are literally not really moving, they're just vibrating in their place. I move it up a little bit. Now they start moving around. They're in constant contact with one another. And if we move this up a lot more, put a lid on just to keep it safe. Then if we look at this area up here, it makes a lot of noise. You can see just a few molecules moving around, and these represent a gas. Let's turn it down a little bit so we can count. So we've got hardly any vibration. And when we've got hardly any vibration, this represents a solid. That's a bit too much. I'm going to have to make it less. There we are. We've got still picking up these right here. We've got the molecules just moving. They're just vibrating. And if Paul brings the camera up a little bit, you might be able to see these just in the centre, just moving. Can you move the camera up a bit so we can see it? Take the camera off. Right. Bring it so you can see it at the side. I've got another video which I did with a different camera, and you see the molecules just vibrating. They're not really moving around very much. So they're just vibrating. Now, that's a solid. If we give them more energy, then they start to move around, but they're still bound to this space. So this is a simulation of a liquid. The molecules can move, but they're still touching one another. And only when I can increase the power considerably can we see these molecules right at the top here, and that represents the gas. They've got lots of energy, but there's very few of them. Okay. Let's review what we've had a look at.
Sorry, I'm not sure.
No. My Alexa device doesn't have any idea either. Okay, let's draw out what we've got to try and make some sense of what's going on. We've got a solid, and in a solid, the molecules are close to one another. There we are, I've got the right screen on now. So this is a solid, and we're seeing merely vibration. Each molecule is sort of just moving a little bit in each direction. In a liquid, molecules aren't any further apart, but they are all moving around, as we saw. But they are constantly touching. And in a gas, these molecules are moving around at high speed. What we have to look at is the change. And in chemistry here, we're interested in the change from going from a solid to a liquid to a gas, or from a gas to a liquid to a solid. And we're going to have a look at an experiment with stearic acid. Stearic acid I've got in at the moment a water bath, so I've got some hot water, we've got some stearic acid, and in here I can put a thermometer. Then you do this at school. What normally happens is you just get a setup very much like this. This hot water getting on for boiling. We've got to get the stearic acid basically above about 75 degrees centigrade. And now we've got it above 75 degrees centigrade. Then what we can do is we're going to take it out and we're going to watch it cool. I've got some software here that's going to try and help us. So I've got my Thank you, Paul. Software here, we've got a temperature sensor, and I'm going to record the temperature every, well, what should we decide on? I can decide on doing this every second. That's probably going to be more than enough. So 1 second's probably going to be good enough. And we'll look at what the temperature is, and we'll time this as we go along. We're going to watch what happens as it cools. So there's the software set up. It's all ready to go. And what I'm just going to do is set it recording. And as we set it recording, we can see at the moment my temperature is at 66.8 degrees centigrade. So I really wanted it a little bit hotter than that. And unfortunately, my system failed. Right. What you were missing there is my stearic acid is solid. I left it too long unattended. I was just heating it up and trying to get it to melt. The water there is boiling, and what I want to do is get all this stearic acid to dissolve and become a liquid, and I have succeeded in doing that, but I have to leave that to the other experiment, and in the meantime the water cools sufficiently. So I'm not using a water bath, I'm just really putting some hot water in here. So let's see what the temperature is doing. It should be rising. The stearic acid is melting. We're getting there. It's nearly all liquid at the moment. And we can see that I've got it up to about 73. I've got to get a bit higher than that. So let's make sure I've got plenty of hot water for this. So easier than in a lab, I can often put the kettle on. Temperature is 75.5. I want it a little bit warmer than that. I need it really above 75, perhaps let's say 80, because it works better. So that all seems to have melted. And our temperature there is 80. So we're doing okay. That thing's in the way. We'll move it over there. We can see we've got, there we are, about 80, which is all right. 81. We'll take it just up if I can, to about 82 or 83. It's gradually creeping up. It takes a little bit of time and effort, especially when you're trying to do experiments live. They don't tend to work necessarily quite as well as I plan them. So we've got the temperature 81.2. Well, I think we might leave it at that. That's probably going to be about the best. And what we're going to do is I'm going to simply take this out and I'm going to put it in here. I'm going to leave it cool in the air. And what we're going to do is record what happens. So Paul will zoom in a sec on that. And what we're going to do is start the experiment. So let's get ready. I don't need all this data, so I'm just going to stop. I'm going to start a new recording. And what we've got is my system going there nicely. You can see we're at 81.1. The water is cooling slowly, 81.0. So let's take it out and put it in the air and see what happens. So we've got that in the air and it will start to cool. And there we're seeing it cool. We've got it down immediately to 73, 72. And we should see this nice steady line going down. Let's have a quick look at the experiment. What can we see going on here? Well, already it's starting to solidify at the bottom. And that was me moving the thermometer. But it's now staying steady. Why is it staying steady at 69.4 or something around about there? What's going on? We can see the temperature is going down very slightly. And we're seeing here it's starting to solidify. We've got liquid at the top, but we've got solid down the bottom. We're staying remarkably stable. I expected this to drop off sharply like it did at this point, but here we're seeing it much more stable. It's not really falling. I had hoped not to have that little bump in it, but we'll see. And it's still staying remarkably stable. It's not falling that much. Odd, it fell a lot. Now it's staying stable at this sort of temperature. So why is this? Well, it is because we're changing state. We can see that the molecules are moving from a liquid, and they're changing to a solid. They're freezing. Seems odd to think that stearic acid is freezing at around about 67, 68 centigrade, but that's its point where it does freeze. That's why we're looking at this particular substance. And we can see that it is gradually getting sort of more fairly solid at the bottom. I don't really want to move the thermometer again because it does ruin the figures. I'd have to keep it moving all the time if I wanted it to work properly, but we're working as usual under more difficult conditions. But the curve is definitely staying fairly straight here. It's not doing an awful lot, just falling down very, very slightly. So what I would be predicting here is a curve looking like this. And that's more or less what we've got. What happens here, I don't know yet, because we basically haven't got there yet. So we've got some idea here of time. I can put in the time here and see how many seconds we've got. We're down to 66. Remarkably flat. Okay. Now, I'm expecting something else to happen. I'm expecting, as this experiment goes on, for something dramatic to happen in a few moments. We're using up a lot of the energy to change state. And we can see this is becoming gradually more and more solid. So it's looking fairly solid now. And what I should expect to see is something happening. And what we have to do here is wait. When I do this experiment as a demonstration on YouTube, quite easily I can compress the time. But here we cannot compress the time. We're just having to watch and see that we've got to about 393 seconds, and still it's just staying at this fairly constant cooling. It is cooling very, very slightly, but it dropped a lot there and then it didn't. And I was expecting this sort of curve. Now, what I'm expecting next is when we've got it all from a liquid phase, and this is the freezing phase, then I'm expecting this to start falling as we get more cooling taking place. This is what was causing my problem when I was trying to heat the substance up, was the fact that I had to actually do the opposite to try and get it to melt, and a lot of energy was required to melt this. We're still on the freezing phase at the moment, nothing else happening. We're not seeing any rapid drop. Although it is starting to look pretty solid there. So we'll wait a moment longer to see whether it's when it's going to kick in and whether we're going to get a nice cooling curve. Still looking remarkably straight. Frustrating for me here. I'm sitting here waiting for it to go, and I know it's going to go. It's just taking a long time. Let's look at a heating curve. if I were trying to heat stearic acid up, and this is sometimes another experiment that I do, if we're getting the students to do this, I get them to do the experiment twice, one heating it up, one cooling it down. We see that the heating goes at a fairly steady pace, and then it stays remarkably steady, and then once it's melted, we go up. So here we've got a liquid. Here we would have the melting phase, and here we're going to have, I got that wrong, didn't I? Sorry, we have the solid, and then we go to the liquid. Another favorite experiment of mine doing the same thing is, and it's much more difficult to do this one, we take some ice cubes. And I can put in here some sort of heater. And if you watched my experiment on physics on the specific heat capacity, it's one of those heaters. We put in some ice cubes and we watch what happens as we start to heat. And as we heat, we find the ice gets hotter. So this is our solid. We then change from our solid to our liquid phase. So here is our melting phase. We then go up as water, and it's interesting to note that these two lines are at different rates. If we're then very clever, we can turn it into steam. And then we will have our boiling, and we'll have solid to liquid to gas. Many students don't seem to understand this idea about you can actually get water hotter simply by heating it after boiling. And to do that, we do a very simple experiment. I'm just keeping track of my stearic acid. It's still not doing very much. It's still cooling at a very slow rate. So while it's still doing that, I'll still carry on with the next bit. So we take a container and something like this. It's called a steam generator. We come out of this copper container and we've got water in here. The water we're supplying lots of heat to, and this water will boil and turn to steam, very much like you have coming out of a kettle. Now, this is where the experiment gets a little bit different. What we can do is typically we put this into a coil. Yeah, we are looking at my art failing. And what I can do is heat this. So we heat the water. The water boils at 100 degrees Celsius. We then continue to heat the water as it goes through here. And we are now superheating the steam. So we are heating the steam. And we can easily get this coming out at 300 Celsius plus, which brings us to a point where we can actually try to light a match with this experiment. And if you want to have a look at this, there's a really nice experiment done by the Royal Institute, their Prep Room Tales, and if you search on YouTube, you can have a look at that. There we are. I'll see if I can put a link in the description a little bit later. Well, it's still cooling very, very slowly. We're at 65. And I'm desperately hoping it's going to go, but it doesn't seem to be. This is now frozen, and it's absolutely solid. And I'm hoping it was going to have a nice cooling going on, but it doesn't seem to be. Well, that's me moving it a little bit. And I think I can put this one down as a bit of a failure for time. It will work, but it's not really doing very much. We might be seeing a slight downturn there. The curve's looking very fractionally steeper. But frankly, I'm not really convinced that this is doing terribly well. It should. So I'm sorry about that. That's the way science works sometimes, especially when you're trying to do live experiments. It should now just be falling a lot quicker. I've left it in a colder environment, so it should manage to do that. It's just we've probably got quite a lot in there, and it's not working as well as I'd like. It's back on its same trajectory as it was before. Having just moved it slightly, you can see it's still at this same sort of cooling rate. And if I put my cooling rate in there. And if we looked at what it was earlier. All right, I'll put another one in. This was cooling at 0.7 degrees Celsius per second. Now we're more or less on 0 per degree Celsius per second, and eventually it will kick in, but we'll probably have to leave that one to see how it's going to go. So not as exciting as I wanted it to be. I expected a little bit more excitement from this one, but it's just not going. We have got, unfortunately, the only bit of this curve that we can actually see is seeing this one. And that's all we're seeing of this curve at the moment. And I was rather desperately hoping that we could see this one. But it's not doing that, is it? So what I'm going to do is I'm going to stop this one. We've been going 18 minutes on this experiment. It's not getting very well. And we'll cheat and we'll have a look at one I did earlier. Yeah, we'll call this one Stearic Acid 2 or something. If I open up an experiment, we have got one. I've got a cooling curve of stearic acid, and I've got a heating curve of stearic acid. Let's look at that one. So this is what I was hoping to do, and get this, and that was the curve that I was expecting to get. So we had constant temperature, cooling, and going down. You can see the time here is quite long. But that's the way it goes. If we just open up our experiment that we just had, what I might be able to do now is set the recording going, and we'll see if we get anything nice going on here. It's still at 58.1, has fallen very slightly, but it's not falling anything like what I was hoping to get. It's still not really in the stage of cooling as much as I'd like. And we're looking at a graph that's not going down much. It's still reckoning on this only falling at less than 0 degrees Celsius per second. It's not doing very well. It's still following that basic track. So we're not getting very far on this one. As soon as you go, I'm sure it's going to fall, and we'll get that curve that I had and showed you a few moments ago. So disappointing, that one didn't work as well as I'd like. And if I want to try and get some of these things to go, then, well, that's why I generally put them up on YouTube. But I'll put some of those up on YouTube, the link to the RI and the other one. So I will see you next time when we'll try and do a bit more exciting bits with chemistry. We're going to look at bond structure and bonding in a bit more detail. This is just starting to have a look at basically the states of matter. And then next time we'll have a look at some other bits and pieces on ionic bonding and possibly covalent bonding as well. So I'll see you soon. Take care. Bye-bye.